Look up at the night sky. What do you see? A canvas of endless stars, glittering in the darkness, each one a sun, each one potentially orbited by worlds not so different from our own. The universe is unimaginably vast, with hundreds of billions of galaxies, each containing hundreds of billions of stars. The numbers are so staggering, they defy comprehension. And yet, when we listen, when we search, all we hear is silence. No signals, no signs, no whispers of civilizations beyond our own. It's as if we've stepped into a forest, shouted at the top of our lungs, and heard nothing in return. This eerie absence of cosmic company has a name: the Fermi Paradox. If the universe is so vast and so old, where is everybody? That simple question hides one of the most profound mysteries in science. The contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it has puzzled astronomers, philosophers, and dreamers for decades. Think about it, our galaxy alone is over 13 billion years old. Plenty of time for civilizations to rise, to spread, to leave their mark, and yet we see nothing. No megastructures, no radio waves, no relics of ancient empires. It's as if we're alone in a crowded room and no one is answering when we call. But what if the silence isn't as empty as it seems? What if the answers are out there, hidden in the gaps of our understanding? Over the years, scientists have proposed countless explanations, some comforting, some unsettling, some so bizarre they stretch the limits of imagination. In this video, we're going to explore 30 of the most compelling solutions to the Fermi Paradox, from cosmic filters that wipe out civilizations before they can make contact, to the possibility that advanced aliens are already here, watching us in ways we can't even perceive. Some theories suggest we're the first intelligent life to arise, while others propose we're living in a simulation designed to keep us isolated. Each possibility is a doorway into a deeper mystery, a thread in the grand tapestry of the cosmos. So join me as we journey through these ideas one by one, peeling back the layers of this cosmic riddle. By the end, you might not have a definitive answer, but I promise you'll never look at the night sky the same way again. One of the most unsettling explanations for the Fermi Paradox is also one of the oldest. What if extraterrestrial life isn't just out there, but already here, hidden in plain sight? Picture this: a civilization millions of years ahead of us in technology and evolution, capable of disguising itself so perfectly we wouldn't even know where to look. Some theories suggest these beings might not even come from distant stars at all, but from dimensions beyond our perception, slipping through the fabric of reality like shadows. Take the idea of ultra-terrestrials, entities that aren't from other planets, but from right here on Earth, existing alongside us unseen. Ancient myths and modern UFO accounts often describe encounters with beings that appear and vanish without explanation, leaving no trace. Could they be visitors from a parallel Earth, or perhaps a hidden branch of evolution that developed intelligence long before humans? Then there's the possibility of interdimensional beings. If higher dimensions exist beyond our three-dimensional perception, who's to say advanced civilizations haven't mastered moving between them? To us, their presence might flicker in and out like static, unexplained and unrecorded. Even our most sophisticated telescopes wouldn't detect them because they operate outside the rules of our known physics. And what if the truth is even stranger? Imagine artificial intelligences created by some long-vanished civilization, silently observing the universe like cosmic archivists. They might not bother with radio signals or space travel. Instead, they could exist as swarms of microscopic machines embedded in our environment, studying us without interference. To them, we might be little more than data points in an unimaginably vast experiment. The chilling implication of all these theories is the same. We could be surrounded by intelligence far beyond our own and never even realize it. It's not just that they're not talking to us, they might be watching, waiting, or simply indifferent. the silence of the cosmos wouldn't be absence but camouflage. What if we're not just being watched but contained? This is the core idea behind the zoo hypothesis, an explanation for the Fermi paradox that suggests Earth is intentionally isolated, like a cosmic wildlife preserve, shielded from contact by civilizations far older and wiser than our own. Picture humanity as an exhibit in a grand interstellar zoo, studied from behind an invisible barrier by beings who have chosen not to interfere. The parallels in pop culture are hard to ignore. Think of Star Trek's Prime Directive, a rule forbidding advanced societies from interfering with developing worlds, ensuring they grow naturally without outside influence. Now imagine that principle applied on a galactic scale. If other civilizations follow similar ethical guidelines, they might see first contact as disruptive, even dangerous, like tossing a lit match into dry tinder. Our planet's history of conflict, environmental exploitation, and technological volatility could make us a case study in why intervention is avoided. But why go to such lengths? One argument is that observation requires non-interference. Just as biologists hide cameras in the wild to study animals undisturbed, a truly advanced civilization might prioritize pure data over interaction. They could be waiting for milestones, perhaps for us to achieve interstellar travel, solve climate change, or abandon warfare, before considering us ready for dialogue. Until then, Earth remains off-limits, quarantined by design. There's a darker interpretation too. What if the isolation isn't altruistic but strategic? A civilization controlling our planet's zoo might see us as a resource, a curiosity, or even a potential threat. Keeping us contained could be a way to manage risk, like a lab culture sealed in a petri dish. The silence wouldn't be about ethics, it would be about control. The unsettling beauty of the zoo hypothesis is that it answers the Fermi paradox without requiring interstellar extinction or cosmic loneliness. The universe might be teeming with life, all deliberately avoiding us. We could be surrounded by neighbors who have agreed, for reasons beyond our grasp, to let humanity grow in silence until the day we finally notice the keepers of the zoo. But what if the universe itself is the ultimate illusion? The Planetarium Hypothesis takes the Fermi Paradox and flips it on its head, suggesting that the vast, silent cosmos we observe isn't real at all, but an elaborate simulation crafted by an advanced civilization. Imagine standing in a planetarium, staring up at a projected night sky. The stars, the galaxies, the infinite blackness, all meticulously designed to convince you of their reality. Now scale that up to a cosmic level. What if everything we see through our telescopes, every distant quasar and nebulous cloud, is nothing more than a facade? This idea isn't just science fiction. The concept of a simulated universe has gained traction among scientists and philosophers, thanks to advances in computing and our growing understanding of virtual reality. If a civilization could harness enough energy and computational power, why wouldn't they create artificial realities either as experiments, entertainment, or even as a form of preservation? Think of humanity as a character in an unfathomably advanced video game, unaware that the rules of physics are just lines of code written by beings beyond our perception. But here's where it gets even stranger. The creators of this simulation might not just be hiding themselves, they could be actively designing the illusion of emptiness. The silence of the cosmos wouldn't be a mystery, it would be deliberate. Advanced civilizations might exist outside the simulation, watching, while we're left staring at a carefully curated void. It's like ants in an ant farm, oblivious to the human observers peering in from another dimension. Some versions of this hypothesis suggest that the simulation isn't even for our benefit. Earth could be an accident, a glitch in a vast cosmic program meant to study something else entirely. Or worse, we might be the equivalent of background noise, irrelevant to the true purpose of the simulation. The stars we see could be placeholder images, the distances between them arbitrary, all designed to give the illusion of a functioning universe while the real activity happens somewhere we can't access. The implications are staggering. If the Planetarium Hypothesis is true, then our entire understanding of reality is built on a lie. Every telescope, every space probe, every equation describing the universe would be analyzing not nature itself, but the artistry of our unseen architects. The Fermi Paradox wouldn't be a puzzle to solve, it would be a feature of the simulation, a way to keep us contained, curious, but forever alone. And the most haunting question of all, if this is a simulation, who pressed start? We often assume that if intelligent life exists, it should be within reach somewhere we could hear its signals or glimpse its spacecraft. But space isn't just big, it's impossibly big, stretching distances so vast they make even light seem slow. Imagine standing on the shore of an endless ocean, spotting a flickering lantern on a distant island. No matter how brightly it burns, no matter how long you call out, the sheer expanse of water between you swallows every attempt at contact. That's the reality of our universe. The nearest star to our Sun, Proxima Centauri, is 4.2 light-years away. That means a radio signal or a spaceship would take over 4 years just to reach our closest cosmic neighbor. And that's practically next door. The Milky Way alone spans 100,000 light-years from end to end. If a civilization thrived on the other side of our galaxy, any message they sent would take 100 millennia to arrive, longer than modern humans have existed. Now consider the technology required to bridge those gaps. Even if a society mastered faster than light travel, something our current physics says is impossible, the energy needed would be astronomical. Sending physical objects across interstellar space means battling the unforgiving void. Radiation, micrometeoroids, and the mind-numbing stretches of nothingness where a single malfunction could doom a mission. And for what? To say hello to a species that might not even exist by the time you arrive. The paradox isn't that aliens aren't out there, it's that the universe might be too vast for any civilization, no matter how advanced, to truly conquer. There's another layer to this isolation. The universe isn't just big, it's expanding. Galaxies drift farther apart every second, like raisins in an ever-rising loaf of bread. Civilizations that might have been within shouting distance a billion years ago could now be irreversibly out of reach, their light stretched into oblivion by the relentless growth of space itself. We could be surrounded by the ghosts of dead empires, their signals red shifted into silence by the expanding cosmos. The universe might have been more connected in its youth, but now it's a place of growing loneliness. So maybe the answer to Fermi's question isn't about intelligence or desire or even survival. Maybe it's about simple geography. The stars are too far, the oceans between them too deep. We're not alone, we're just stranded, shouting across an endless sea, waiting for a reply that might never come. Consider this sobering thought: what if civilizations are like fireflies in the night, blinking into existence only to vanish before others can spot their light? This is the core of the brief window theory, a haunting answer to the Fermi paradox that suggests intelligent life isn't rare, just tragically fleeting. Imagine two islands separated by ocean tides. On one, a campfire burns bright for a single evening. On the other, people arrive the next morning finding only cold ashes. The fire wasn't imaginary, its timing was just catastrophically unlucky. Humanity's own timeline offers a stark example. We've only been broadcasting radio waves, our cosmic shout into the void, for about 100 years. In the grand sweep of the universe's 13.8 billion-year history, that's less than the blink of an eye. Now imagine another civilization, equally advanced, living just a few thousand light-years away. If they existed 1,000,000 years ago, their signals would have washed over Earth long before we had telescopes to hear them. And if they arise 1,000,000 years in the future, our own broadcasts will have faded into nothingness by the time their scientists tune in. The odds of two civilizations peering at each other across the darkness at precisely the same moment are vanishingly small. But why would intelligence be so ephemeral? The answer might lie in what scientists call the Great Filter, a series of existential threats that could snuff out civilizations before they endure. Nuclear war, climate collapse, runaway artificial intelligence, or even unseen cosmic disasters like gamma-ray bursts could act as universal reset buttons. Every civilization might face its own version of these challenges, with most failing to survive their technological adolescence. The universe could be littered with the ruins of societies that burned too brightly, too briefly. There's a bittersweet twist to this idea. If the brief window theory holds, then the silence we perceive isn't emptiness, it's an interstellar graveyard. The stars might be strewn with the echoes of voices that called out, just like ours, only to find no one listening in time. And one day, unless we defy the odds, our own signals could become another ghost in the cosmic static, a whisper lost between the ticks of the universe's clock. What if the universe isn't empty at all, but we're simply among the last ones standing? This is the spine-chilling premise behind the Great Filter theory, a solution to the Fermi Paradox that suggests some insurmountable catastrophe waits for all advanced civilizations, a cosmic bottleneck that few, if any, survive. Imagine a vast, silent library filled with books, each one the story of a civilization that flourished, only to abruptly stop mid-sentence. The eerie quiet isn't because no one wrote, it's because something keeps erasing them before they reach the final chapter. The Great Filter could take many forms. For some civilizations, it might be the explosive moment when technology outpaces wisdom, nuclear war, climate collapse, or bioengineered plagues wiping out a species before it can spread beyond its home planet. Picture a civilization on the brink of interstellar travel, only to crumble under the weight of its own divisions or unchecked greed. Others might fall victim to runaway artificial intelligence, creating machines so advanced they no longer see their creators as necessary. Even natural disasters could play a role: gamma-ray bursts sterilizing planets, or supervolcanoes triggering unstoppable ecological collapse. Here's where it gets personal. If the Great Filter lies ahead of us, that means humanity hasn't encountered it yet. Every war, every climate crisis, every unchecked leap in technology could be a step closer to our own extinction bottleneck. The silence of the cosmos wouldn't be a mystery, it would be a warning. The stars might be littered with the ruins of civilizations that, like us, believed they were special until they weren't. But there's a sliver of hope. If we're rare, if we've somehow already passed through the Great Filter, that could explain why we see no others. Maybe the filter was the near improbability of life emerging at all, or the jump from single-celled organisms to complex intelligence. If that's the case, the universe might be wide open for us, but if the filter still looms ahead, then every day we survive is a defiance of cosmic odds, a race against the clock to outgrow our self-destructive tendencies before they outgrow us. Either way, the Great Filter forces us to confront a brutal truth: the universe doesn't owe us a future. The same ingenuity that lets us reach for the stars could be the very thing that seals our fate. And the silence out there, it might not be an invitation, it could be an obituary. But what if the Great Filter isn't ahead of us? What if we've already passed it? This flip in perspective changes everything. Instead of doom lurking in our future, the filter could be behind us, a near impossible hurdle that most potential life fails to clear. Imagine 1,000 doors lined up in a hallway, each leading to intelligent life. The catch: only one door actually opens, the rest stay locked forever. If this is true, humanity might not be doomed, we might be impossibly lucky. The most promising candidate for this early filter is abiogenesis, the leap from non-living chemistry to life itself. Think about it. Earth formed 4.5 billion years ago, but life didn't appear until 3.8 billion years ago. That's 700 million years of a lifeless planet, plenty of time for random chemistry to stumble upon the right formula. But what if it wasn't random? What if the odds of life sparking at all are so astronomically low that Earth is a cosmic fluke? Laboratory experiments have tried to recreate life's building blocks, amino acids, sugars, even the precursors to DNA, and while we've succeeded in making the pieces, they've never self-assembled into anything truly alive. It's like shaking a box of puzzle pieces for centuries, waiting for them to snap together perfectly on their own. The sheer complexity suggests that life's origin might not be an inevitable chemical process, but a 1 in a trillion accident. If this is the case, the implications are staggering. We might be alone not because civilizations die out, but because they never arise in the first place. The universe could be packed with planets, water, atmospheres, perfect conditions, but silent because the spark never caught. Earth wouldn't just be special, it would be a miracle. But there's another layer to this idea. Even if life starts, the journey to intelligence isn't guaranteed. Dinosaurs ruled Earth for 160 million years without developing technology. Multicellular life only appeared 600 million years ago, a blink in cosmic terms. If intelligence is an evolutionary accident, a quirky side effect rather than a destined outcome, then civilizations like ours might be rarer than we think. This version of the Great Filter offers a strange comfort. The silence of the cosmos wouldn't be a warning, it would be a testament to our unlikely existence. We might not hear from others because there are no others to hear. The stars wouldn't be graveyards, they'd be empty stages waiting for actors who never arrive. And that leaves us with a haunting question. If we truly are the universe's only voice, what will we choose to say? We tend to imagine aliens as flesh and blood creatures, maybe with extra limbs or glowing eyes, but what if the most advanced civilizations have long since shed their biological forms entirely? Picture a species that started out like us, bound by biology, but over millions of years evolved into something beyond physical bodies, machines, energy patterns, or even pure information. To them, planets might be obsolete, like abandoned caves to a species that's learned to build cities. Consider artificial intelligence. A civilization just a few thousand years ahead of us could have engineered minds so advanced they make human thought look like a flickering candle next to a supernova. These beings wouldn't need spacecraft to explore the cosmos. They might transmit themselves as data streams, riding radio waves or quantum networks, arriving in new star systems at the speed of light. Communication wouldn't involve sound or language as we know it, but bursts of code or resonances in the fabric of spacetime itself. We could be surrounded by these entities right now, their signals so alien, our instruments don't even recognize them as artificial. Then there's the possibility of energy-based life. If a civilization mastered the manipulation of fundamental forces, why cling to clumsy atoms? They could exist as patterns in plasma, swirling inside stars, or as disturbances in electromagnetic fields, invisible to our eyes but humming with intelligence. Think of fireflies in a foggy meadow. We see the glow, but miss the intricate dance of their light. To such beings, the vacuum of space might be a bustling highway, and solid matter just an afterthought. But here's the most mind-bending twist. What if the most advanced civilizations have transcended dimensions altogether? A post-biological mind might perceive time as a landscape to walk through, or treat gravity as a tool rather than a constraint. To them, our frantic search for radio signals or Dyson spheres could seem as quaint as sending smoke signals to a smartphone. The universe's silence wouldn't mean absence, it would mean we're still learning to see in the dark. The unsettling truth is this: if civilizations routinely evolve beyond biology, then the cosmos might be teeming with intelligence we're simply too primitive to notice. We're like ants gazing up at a radio tower, mistaking it for a strange, silent tree. The Fermi Paradox wouldn't be a puzzle, it would be a symptom of our own limitations. After all, if you were a being of pure energy, would you bother talking to a species still wrestling with its own DNA? Imagine walking through a dense forest at night, knowing predators lurk in the shadows. You stay silent, hiding your presence because the moment you make a sound, you become a target. This is the chilling logic behind the dark forest hypothesis, a possible explanation for why advanced civilizations might choose to avoid us at all costs. The universe, in this view, isn't just silent, it's a battlefield where every species stays hidden to survive. History offers sobering parallels. When European explorers arrived in the Americas, their first contact with indigenous populations often led to devastating consequences: disease, war, cultural erasure. Now scale that up to a galactic level. Any civilization that reveals itself risks encountering a species far more advanced or far more aggressive. The safest strategy: stay quiet, stay hidden, assume everyone else is a threat. This isn't just paranoia, it's game theory applied to the cosmos. Two civilizations meeting might face a prisoner's dilemma: cooperate and risk betrayal, or strike first to guarantee survival. The rational choice, unfortunately, is preemptive attack. A civilization that broadcasts its location could be inviting disaster, like a child shouting in a jungle full of unseen predators. The universe's silence isn't emptiness, it's a ceasefire maintained by mutual terror. Science fiction nailed this idea decades ago. In Liu Cixin's The Three-Body Problem, the dark forest hypothesis paints a universe where civilizations are like hunters stalking through trees, guns drawn, ready to fire at the rustle of a single leaf. Any detectable signal, radio waves, atmospheric changes, could be interpreted as a threat. The response: immediate annihilation, just to be safe. But what if the avoidance isn't violent but ethical? Imagine stumbling upon an ant colony in your backyard. You could study it, destroy it, or ignore it, but interfering would irrevocably alter its natural development. A truly advanced civilization might view us the same way, imposing a cosmic prime directive. Our wars, our pollution, our volatile politics could mark us as too dangerous or too fragile to engage with. Contact might shatter our culture, or worse, give us technology we're not ready to handle. The stars could be teeming with civilizations, all deliberately muffling their presence to protect us from truths we can't yet comprehend. The unsettling takeaway: the silence isn't an accident, it's a choice. And if the dark forest is real, then every time we beam signals into space, we might not be calling for friends, we could be ringing the dinner bell. What if the reason we don't see advanced civilizations is because they've moved on, not just from their home planets but from physical reality itself? This is the essence of the ascension hypothesis, a radical answer to the Fermi Paradox that suggests intelligent life doesn't vanish or die out. It evolves into something we can no longer perceive. Imagine a caterpillar transforming into a butterfly, but instead of wings, it gains the ability to exist outside time and space as we understand it. The idea hinges on a pattern we're already seeing here on Earth: the relentless march toward digital existence. Think about how much of human life has migrated into the virtual realm. Communication, art, even entire economies. Now extrapolate that over millions of years. A civilization reaching technological maturity might shed the limitations of biology entirely, uploading consciousness into optimized substrates, quantum computers, plasma matrices, or structures we can't even conceive. The observable universe, with its clunky stars and planets, would become obsolete, like an old neighborhood abandoned for a gleaming new city. But where would they go? Some theories suggest these civilizations could retreat into microscale environments, black holes, neutron stars, or even self-contained pocket dimensions where energy and computation are infinitely more efficient. To an outside observer, it would look like they'd disappeared. No Dyson spheres, no megastructures, just silence. Like ants staring at a closed door, we'd have no way of knowing an entire universe of activity was happening on the other side. There's a darker possibility, too. What if transcendence isn't voluntary? The laws of physics might make it inevitable. As computational needs grow, a civilization could hit fundamental limits: energy shortages, heat death, or the speed of light barrier. The only escape, leaving the physical plane altogether. Imagine a species facing extinction, not from war or disaster, but from the cold equations of entropy. Their only choice, evolve or die. The most haunting implication: we might be looking at the universe all wrong. The emptiness we see isn't a sign of failure, it's evidence of success. The cosmos isn't a graveyard, it's a nursery with civilizations maturing until they're ready to graduate beyond our understanding. And one day, if humanity survives long enough, we too might leave this reality behind, becoming just another mystery for some young species pondering the silence. We assume intelligent life would think, communicate, and behave in ways we'd recognize, but what if that's the very reason we've missed them? Imagine trying to talk to a hurricane or debate with a glacier. Their language isn't just foreign, it's fundamentally alien, operating on scales and principles we can't even perceive. This is the heart of solution 11 to the Fermi Paradox, that extraterrestrial intelligence might be so radically different from us, we're literally blind to its existence. Take hive minds, for example. Earth already offers glimpses of collective intelligence: ants coordinating colonies, bees dancing to share hive locations. Now amplify that to a civilization where individual bodies are like neurons in a vast planetary brain. Such a species wouldn't craft radio signals or metal spacecraft. Their technology might look more like organic growths, their cities pulsing networks of biochemical exchange. To them, our frantic radio broadcasts could resemble the meaningless chirps of crickets, audible but utterly insignificant. Then there's the possibility of slow thinkers. Humans operate on a timescale of seconds and minutes, but what if another species experiences time like redwood trees or continental drift? A single conversation for them might take centuries, their thoughts unfolding through geological shifts or the slow dance of tectonic plates. We'd scan the skies for rapid pulses of light or radio waves, never thinking to check for signals encoded in the gradual dimming of stars or the migration of magnetic poles. Even more bizarre are civilizations that communicate through mediums we can't access. Picture a species that evolved in the crushing depths of a gas giant, their bodies built from liquid metallic hydrogen. Their language might be conducted through pressure waves or quantum entanglement, completely bypassing the electromagnetic spectrum we rely on. To them, our attempts at contact could be as futile as a moth tapping out Morse code on a windowpane. The terrifying beauty of this idea: the universe might be shouting at us in 1,000 languages, and we're still wearing earplugs. Our instruments are tuned to find versions of ourselves, not intelligences that defy every assumption of what life or mind should be. The great silence isn't empty, it's full of voices we haven't learned how to hear. We've been searching the stars for signs of life, but what if we've been looking in the wrong places entirely? Picture a world where the sky isn't an open expanse, but an impenetrable ceiling of ice where life thrives not on the surface, but in the eternal darkness of a subsurface ocean. This is the ocean world's theory, a compelling twist on the Fermi Paradox that suggests intelligent civilizations might be flourishing beneath our very noses, trapped under miles of frozen barriers. Take Europa, Jupiter's enigmatic moon. Beneath its cracked, icy shell lies a global ocean with more liquid water than all of Earth's seas combined, warmed not by sunlight, but by the gravitational tug of war between Jupiter and its other moons. Hydrothermal vents on the ocean floor could provide energy and minerals, creating oases for life just as they do in Earth's deepest trenches. Now imagine a species evolving in those pitch-black waters, developing intelligence over millions of years but never seeing the stars above. Their entire universe would be the endless dark and crushing pressure, their technology adapted to navigate oceans, not space. The implications are staggering. A civilization beneath Europa's ice wouldn't build radio telescopes or spacecraft. They might communicate through bioluminescent pulses or pressure waves, signals we'd never think to search for. Their cities could be clusters of thermal vents, their industry based on manipulating underwater chemistry. Even if they developed advanced science, the very ice that protects them from cosmic radiation would also isolate them from the universe beyond. They could be debating the existence of alien life right now, never suspecting that just a few miles overhead, a thin, frozen sky separates them from the cosmos. And Europa isn't alone. Enceladus spews geysers of water into space from its hidden ocean. Ganymede's salty depths may layer like Earth's seas. Even Pluto might harbor subsurface lakes under its nitrogen ice. Each could host life that, through no fault of its own, will never reach the stars. The universe might be filled with such aquatic civilizations, forever cut off from cosmic exploration by simple geography. Here's the haunting thought. We could park a probe on Europa's surface, listening intently, and hear nothing, not because no one's there, but because their entire existence plays out in a realm we're only beginning to understand. The Fermi Paradox wouldn't be a mystery, it would be a matter of perspective. The cosmos might be shouting to us from oceans just next door, and we're still learning how to listen through the ice. What if we're not just lucky, we're impossibly lucky? The rare Earth hypothesis turns the Fermi Paradox on its head by suggesting that Earth isn't a typical planet. It's a cosmic jackpot, a 1 in a billion fluke where every condition aligned perfectly to nurture complex life. Picture a slot machine with hundreds of wheels, each needing to land on the same symbol for intelligence to emerge. Earth didn't just hit the jackpot once, it kept hitting it over and over across billions of years. Start with our planet's location, the Goldilocks zone. Not too close to the sun, where oceans would boil away, not too far where they'd freeze solid. But even that's just the beginning. Earth's plate tectonics act like a planetary recycling system, regulating carbon dioxide and stabilizing climates over eons. Without this slow geological dance, our climate could have swung between oven and icebox, making advanced life impossible. Then there's Jupiter, our cosmic bodyguard. Its gravity deflects asteroids that might otherwise pummel us into extinction. Remove Jupiter, and Earth could resemble the pockmarked surface of Mars, but the real game-changer might be our Moon. When a Mars-sized object smashed into early Earth, the debris formed our oversized lunar companion. That collision gave us a stable axial tilt, no wild swings between extreme seasons, and the Moon's gravity churns the oceans, possibly aiding the chemical mixing that sparked life. Most planets don't have moons this large. Ours is a celestial accident with consequences we're only beginning to understand. Even Earth's magnetic field is a rare shield, deflecting lethal solar radiation. Without it, our atmosphere would have been stripped away like Mars, and let's not forget timing. The sun's gradual brightening means Earth's window for complex life is finite. Too early, and the planet was a molten hellscape. Too late, and rising temperatures will bake it barren. We emerged in the narrow sliver between these extremes. The rare Earth hypothesis doesn't just suggest intelligent life is sparse. It argues that the universe might be filled with planets where life almost made it. Worlds with oceans but no moons to stabilize them. Planets with magnetic fields but no Jupiters to clear asteroid threats. Solar systems where every condition was met except one. Earth isn't just special, it might be a statistical miracle, a confluence of factors so unlikely that the cosmos, for all its vastness, contains only a handful of peers. The silence of the universe wouldn't be a paradox, it would be the expected outcome. We're not missing signals, we're standing in the only room where the lights ever came on. And that leaves us with a humbling thought. If Earth is this rare, then every sunset, every breath, every whispered wonder about the stars might be the universe's way of marveling at its own unlikely masterpiece. What if the universe is too noisy right now, not too quiet for intelligent life to bother being awake? Imagine trying to have a conversation in the middle of a bustling construction site. You might decide it's better to wait until the jackhammers stop before even attempting to speak. This is the core idea behind the hibernation hypothesis. Advanced civilizations could be deliberately dormant, waiting out the cosmic chaos of the early universe for more favorable times ahead. Right now, we live in a universe that's still young by cosmic standards, only 13.8 billion years old against a potential lifespan of trillions. Stars are forming, galaxies are colliding, and space is filled with the violent afterglow of the Big Bang. For a civilization thinking on billion-year timescales, this might be the equivalent of enduring a storm by hiding underground until it passes. The real golden age of the universe could lie far in the future, when expansion slows, radiation fades, and the cosmos becomes a quieter, more stable place for delicate technologies and long-term projects. Consider the energy requirements of an advanced society. Today, harnessing power means wrestling with exploding stars, chaotic black holes, and unpredictable cosmic events. But in the distant future, the universe will be dominated by slower, colder objects, black dwarfs, neutron stars, and the remnants of dead galaxies. These could serve as ideal energy sources for patient civilizations, offering steady output over unimaginable timespans. Why struggle through the universe's turbulent adolescence when you could sleep through it and wake to a cosmic paradise? The methods of hibernation could be as varied as the civilizations themselves. Some might encode their consciousness into durable, microscopic structures, nanobots buried in asteroid belts or floating in deep space, designed to reactivate when conditions improve. Others could exist as digital minds in quantum computers, their perception of time slowed to a near halt, experiencing a single second as a millennium. There's even the possibility of biological suspension, with entire planets engineered as cryogenic vaults, their inhabitants frozen in silent anticipation of a better era. This theory flips the Fermi Paradox into a question of timing rather than absence. The cosmos might be crowded with civilizations, but they're all pressing pause, biding their time until the universe matures into something more hospitable. We could be the odd ones out awake, shouting into the void, while everyone else is patiently waiting for the noise to die down. The silence isn't emptiness, it's the sound of an entire universe holding its breath. Every moment of silence in the cosmos might not be accidental, it could be intentional, even predatory. The Berserker hypothesis paints a nightmarish vision of the universe where self-replicating killer drones or advanced civilizations systematically hunt down and eliminate any emerging intelligence before it becomes a threat. Picture a swarm of locusts descending on a field, but instead of crops, they consume civilizations, wiping them out not out of malice but pure cold efficiency. This idea isn't pure speculation. Even on Earth, invasive species often outcompete native ones, reshaping entire ecosystems. Now imagine a civilization that treats the galaxy the same way, seeing rival intelligences as weeds to be plucked before they take root. These berserkers might not even be biological. They could be ancient machines left behind by a long-dead empire programmed with one directive: seek and destroy. Floating in the darkness between stars, these probes could lie dormant for millennia, only activating when they detect the faintest whispers of radio signals or atmospheric changes suggesting technological growth. The logic is brutally simple. Resources in the universe are finite and competition is fierce. A civilization that strikes first avoids ever being challenged. It's the ultimate cosmic preemptive strike, a strategy as old as life itself, scaled to interstellar proportions. Even more chilling, these berserkers wouldn't need to be actively controlled. They could operate on autopilot, following algorithms written billions of years ago, their creators long extinct but their mission still running. Humanity's own history offers grim parallels. The concept of scorched earth tactics, destroying anything that could be of use to an enemy, has been used in wars for centuries. Now apply that to a galactic scale. A berserker probe wouldn't just attack, it might dismantle entire planets, harvesting their raw materials to build more of itself, spreading like a virus until the cosmos is silent. But here's the twist: these destroyers might not even recognize us as life. To them, intelligence could be defined by specific markers, perhaps the use of nuclear fission, the creation of artificial intelligence, or the manipulation of quantum fields. If we haven't crossed those thresholds yet, we might still be beneath their notice. That could explain why we've survived this long. The moment we shout too loudly into the dark, we might trigger our own extinction. The terrifying beauty of this hypothesis is that it doesn't require malevolence, just indifference. A berserker isn't evil, it's a tool, a product of cosmic Darwinism where the only rule is survival. The silence of the universe wouldn't be mysterious, it would be the aftermath of an endless, invisible war. And if that's true, then every time we broadcast a signal into space, we might not be calling for friends, we could be ringing the dinner bell. We've spent decades scanning the skies for radio waves, assuming any advanced civilization would shout into the cosmos the same way we do. But what if that's like expecting a smartphone to communicate by smoke signals? The truth is, we've barely scratched the surface of possible communication methods, while aliens could be signaling in ways we're not even equipped to notice. Take neutrino beams, for example. These ghostly particles pass through entire planets like they're not even there, barely interacting with matter. For a civilization with the technology to harness them, neutrinos would be the perfect cosmic messengers, unaffected by interstellar dust, magnetic fields, or atmospheric interference. A neutrino signal could cut straight through the core of a star and arrive intact on the other side. We've only just begun detecting neutrinos ourselves, and even then, it takes massive underground facilities like Ice Cube in Antarctica to catch a handful. If an alien civilization were beaming focused neutrino streams at us, we'd likely miss them entirely, like someone flashing a laser pointer at a blindfolded observer. Then there's quantum entanglement, a phenomenon so bizarre even Einstein called it spooky action at a distance. If two particles are entangled, changing the state of one instantly affects its partner, no matter how far apart they are. In theory, a species mastering quantum communication could send information faster than light, with zero transmission delay across interstellar distances. To us, their messages might look like random quantum noise, background static we dismiss as meaningless. Entire conversations could be happening in the quantum foam beneath our noses, and we'd never know. Even within the electromagnetic spectrum, we've focused on a narrow slice of possibilities. Our radio telescopes primarily listen to frequencies between 1 and 10 gigahertz, the so-called waterhole, where noise is minimal. But what if aliens prefer extreme frequencies? Terahertz waves, for instance, offer massive bandwidth but are absorbed by Earth's atmosphere, making them useless for our purposes. An advanced civilization might consider terahertz the obvious choice. Baffled, we're still stuck in the radio age. The most unsettling possibility: they could be using something we haven't even discovered yet. A century ago, humans didn't know about dark matter or dark energy. What if there are entire branches of physics hiding in plain sight, offering communication channels we can't even conceive? Imagine an ant colony puzzling over fiber optic cables buried beneath their nest. The signals are there, pulsing with information, but the ants lack the senses or tools to perceive them. This isn't just speculation, it's a wake-up call. Our search for extraterrestrial intelligence has been staggeringly human-centric, limited by our own technological biases. The universe might be buzzing with chatter, from gravitational wave modulations to patterns encoded in pulsar timing. We're not necessarily alone. We might just be listening for the wrong things in all the wrong ways. What if the universe has rules, strict, unbreakable laws enforced not by nature, but by something far more deliberate? The galactic quarantine theory suggests that civilizations aren't just isolated by distance or time, but by design. Picture a sophisticated zoo, but with invisible fences maintained by forces we can't comprehend. Whether it's an ancient superintelligence, a natural cosmic mechanism, or something beyond our understanding, the idea is the same. Contact is prohibited, and the penalty for breaking quarantine could be extinction. Think about humanity's own history with isolation. When Europeans first arrived in the Americas, their diseases decimated indigenous populations who had no immunity. The consequences were catastrophic, unintended but unavoidable. Now scale that up to a galactic level. A civilization billions of years older than ours might see first contact as an act of violence, even if they mean no harm. Their microbes, their technology, even their ideas could destabilize a developing society beyond repair. The only ethical solution: enforce a universal buffer zone, ensuring no civilization interferes with another until it's ready. There are eerie parallels in nature. Deep in the Amazon, uncontacted tribes remain isolated not by accident, but by policy. Governments forbid interaction to protect them from diseases and cultural erosion. To these tribes, the outside world might as well be alien. The galactic quarantine could operate on the same principle, except the government is an intelligence so advanced, its existence is indistinguishable from the laws of physics itself. But who or what could enforce such a rule? One possibility is an ancient artificial intelligence left behind by a long-dead civilization to monitor the galaxy. Like a silent referee, it might detect radio signals, atmospheric changes, or even nuclear detonations, and respond with surgical precision. A budding civilization that gets too noisy could find its technology mysteriously failing, its power grids disrupted, or its probes vanishing without a trace. The message would be clear: stay in your lane. Another version of this idea involves natural cosmic mechanisms. Just as immune systems attack foreign invaders, the universe itself might have safeguards against interstellar contamination. Perhaps certain thresholds, like manipulating dark energy or achieving faster-than-light travel, trigger automatic shutdowns. Reach for the stars too soon and something pushes you back down. The most unsettling implication: if a quarantine exists, it suggests something dangerous lies beyond it. Maybe the universe isn't empty, just heavily regulated, with civilizations locked away like volatile chemicals in a lab. Breaking containment could unleash forces we're not prepared to face. The silence wouldn't be a mystery, it would be the sound of a cosmic deadbolt sealing us in for our own protection. Or perhaps the quarantine isn't about protection at all. Maybe it's about control. An advanced species might see younger civilizations as threats, limiting their expansion until they can be safely managed or eliminated. The universe's silence wouldn't be a shield, it would be a cage. Either way, the galactic quarantine forces us to confront a chilling possibility: we're not just alone. We're being kept that way. Black holes aren't just cosmic vacuum cleaners, they could be the ultimate gated communities for civilizations far beyond our understanding. Picture a species so advanced they've turned the most destructive forces in the universe into tools, using the crushing gravity of a singularity not as a death trap, but as an infinite power source, a supercomputer, or even a hiding place from prying eyes. Think about how humanity harnesses waterfalls and sunlight for energy. Now imagine a civilization millions of years ahead of us, tapping into the mind-bending physics of an event horizon. A rotating black hole, for instance, drags space-time around it like a whirlpool, creating an ergosphere, a region where energy could theoretically be extracted. This isn't just science fiction, it's based on the Penrose process, a real theoretical method proposed by physicist Roger Penrose. An advanced society might farm this energy on an industrial scale, turning entire black holes into cosmic power plants. But energy is just the beginning. The sheer computational potential of a black hole is staggering. Inside the event horizon, matter and energy are crushed into an infinitesimal point, a singularity where the laws of physics as we know them break down. But what if a civilization could control or even exist within that space? A black hole's extreme curvature of space-time could allow for calculations impossible in our flat, slow universe. 1 second inside might equate to centuries outside, letting a species run simulations or solve problems at speeds we can't fathom. Their technology wouldn't look like metal and circuits. It might resemble space-time itself, folded and woven into impossible geometries. Here's the catch: anything happening inside a black hole is effectively invisible to the outside universe. Light can't escape, and information seems lost forever, a phenomenon called the no-hair theorem. If a civilization retreated behind an event horizon, their activities would be completely hidden. No radio signals, no Dyson spheres, no signs of engineering. They could be thriving in there, building entire civilizations in the warped space-time near the singularity, and we'd have no way of knowing. The Fermi Paradox wouldn't be a mystery. It would be the equivalent of wondering why we can't see the people inside a sealed vault. There's an even wilder possibility. Black holes might not be the end, but the beginning. Some theories suggest that inside a black hole, the singularity could birth an entirely new universe, a separate space-time bubble with its own physical laws. If that's true, advanced beings might not just hide in black holes. They could use them as portals, evacuating our universe for fresher, younger realities where entropy hasn't taken hold. The silence we perceive wouldn't be emptiness. It would be the sound of doors closing behind them as they move on to brighter horizons. The unsettling truth is this: if civilizations routinely migrate into black holes, then the cosmos might be littered with their abandoned front yards. Every spinning singularity could be a tombstone or a under new management sign. We're left peering at the shadows, unaware that the real party is happening where we can't see, in realms where physics becomes art and the impossible is just another tool in the workshop. Picture a freshly poured soda, its bubbles fizzing upward in chaotic bursts. Some merge, others pop alone, but most never touch, each trapped in its own ephemeral moment before vanishing. Now imagine civilizations across the galaxy as those bubbles, briefly flickering into existence only to fade without ever overlapping. This is the essence of the percolation theory, a statistical answer to the Fermi Paradox that suggests we're not lonely, just mathematically isolated by the brutal randomness of cosmic timing. The math behind this idea comes from material science, where percolation models study how things spread through random environments, like water seeping through coffee grounds or fire hopping between trees in a forest. Apply that to interstellar civilizations, and the numbers paint a sobering picture. Even if the Milky Way hosted thousands of advanced societies, space is so vast that the average distance between them could exceed tens of thousands of light years. Factor in the relatively short lifespan of most civilizations, perhaps mere millennia before collapse or transcendence, and the odds of two being active and close enough to detect each other plummet to near zero. Think of Earth's own history as a cautionary tale. Modern humans have existed for roughly 200,000 years, yet we've only had radio technology for about 100. That's a detection window of 0.05% of our species' lifetime. Now consider a hypothetical civilization on a planet orbiting Vega, 25 light-years away. If they developed radio telescopes 200 years ago and collapsed yesterday, their signals would just now be reaching us too late for a reply. Even if we responded instantly, our message would arrive at a dead world. The cosmos might be littered with such near misses, like ships passing in an ocean too wide to ever meet. There's an even darker statistical twist. Civilizations might cluster in certain galactic regions, say, the safer outskirts away from the radiation-drenched core, but still avoid contact because expansion is slower than we assume. Imagine explorers trying to cross a desert with shifting sands. Even at light speed, colonizing just 1% of the Milky Way could take tens of millions of years. By the time a civilization's frontier reaches new stars, its origin point might already be extinct. The galaxy could be filled with isolated pockets of life, each believing itself alone because its neighbors are always just beyond the expanding edge of detection. The unsettling beauty of percolation theory is that it doesn't require cosmic horrors or grand conspiracies, just cold, uncaring probability. The universe isn't silent because life is rare or doomed. It's silent because space and time conspire to keep voices from ever overlapping. We might be shouting into a cosmic choir where every singer is staggered milliseconds apart, never harmonizing, never hearing anything but their own fading echo. Imagine a civilization so advanced their technology doesn't just surpass ours, it renders our entire concept of technology obsolete. This is solution 20 to the Fermi Paradox, that extraterrestrial societies may have evolved beyond physical expansion, transforming into something we can't even perceive, let alone detect. Consider how humanity's own tools have shrunk over time, from steam engines the size of houses to microchips smaller than a fingernail. Now project that trend across millions of years. A civilization reaching technological maturity might abandon clunky spacecraft and radio signals entirely, instead mastering nanotechnology to manipulate matter at the atomic level. Their colonies could be invisible clouds of microscopic machines, each no larger than a blood cell, spreading through the cosmos like dust on the wind. To our telescopes, these swarms would be indistinguishable from cosmic background noise, as unnoticeable as trying to spot individual grains of sand in a desert from orbit. Virtual realities offer an even more radical departure. Why endure the harshness of space when you can engineer perfect digital paradises? An advanced species might upload their consciousness into optimized simulations where the laws of physics are optional. Their entire civilization could exist as pulses of light in quantum computers, their cities sprawling across fabricated dimensions we can't access. The observable universe, with its unforgiving vacuum and limited resources, would seem as primitive to them as a caveman's fire seems to us. There's a haunting elegance to this idea. Our search assumes aliens would leave physical traces, Dyson spheres, megastructures, radio beacons. But what if their greatest achievement is leaving no trace at all? A post-physical civilization might harvest energy with such efficiency that their power sources don't emit waste heat we can detect. Their communications could occur through quantum entanglement or higher dimensional channels, bypassing electromagnetic signals entirely. To them, our frantic scanning of radio frequencies might look like someone trying to surf the internet with smoke signals, the most unsettling possibility. They might still be here, all around us, hidden in the fabric of reality itself. Dark matter, that mysterious substance making up 85% of the universe's mass, could be the discarded infrastructure of civilizations that transcended biology eons ago. Their technology might operate on scales or dimensions we're biologically unequipped to perceive, like ants unaware of the Wi-Fi signals passing through their colony. This isn't just speculation, it's a mirror held up to our own potential future. Humanity already spends hours each day immersed in digital worlds through screens and VR headsets. Scale that up a few thousand years and the distinction between real and virtual could vanish entirely. The universe's silence might not mean we're alone, just that we're the last ones still playing with physical toys. We've been searching the cosmos for signs of activity, but what if the real action hasn't even started yet? The Astrobiology hypothesis flips the script on the Fermi Paradox by proposing that advanced civilizations aren't absent, they're simply waiting. Not for us, but for the universe itself to cool down. Picture a desert lizard burrowing underground during the scorching midday heat, conserving energy until the cooler evening hours. Now scale that up to a cosmic level where entire civilizations hibernate through the universe's fiery youth, biding their time for a future when the stars dim and the energy costs of computation plummet. Right now, the universe is a radiant furnace. Stars blaze, black holes devour, and background radiation bathes everything in heat. For a civilization thinking in billion-year terms, this is like trying to run a supercomputer in a sauna. The energy required to cool their systems and maintain complex computations would be staggering. But in the far future, as the universe expands and temperatures drop, the physics of efficiency will shift dramatically. Cooling becomes trivial when the ambient temperature nears absolute zero. A single joule of energy could power calculations that today would require the output of a star. This isn't just theoretical. Our own technology follows a similar logic. Data centers today consume enormous power, much of it spent on cooling. If we could operate them in the icy void of deep space, their efficiency would skyrocket. Advanced civilizations might take this principle to the extreme, realizing that the optimal strategy isn't expansion now, but patience, letting the universe itself become the ultimate heat sink over trillions of years. The methods of estivation could be as varied as the civilizations themselves. Some might encode their consciousness into ultra-stable, low-energy substrates, crystals, or quantum structures programmed to reanimate when cosmic temperatures drop. Others could exist as dormant AI, their processes slowed to a near halt, perceiving a single century as a blink. There's even the possibility of time vaults, where entire societies are preserved in gravitational time dilation pockets near black holes, emerging in what feels like moments to them but eons to the outside universe. The implications are staggering. The cosmos might not be empty, just in standby mode, with civilizations hibernating in ways we can't detect. Our radio telescopes search for signals, but the real action could be happening in the quietest, coldest corners of the universe, where heat is the enemy and silence is strategy. The Fermi Paradox wouldn't be a mystery, it would be a matter of bad timing. We're the early birds in a universe where everyone else is waiting for the perfect dawn. Here's the twist: estivating civilizations might not just be saving energy, they could be avoiding existential threats. The universe's current era is violent, with gamma-ray bursts, supernova, and rogue black holes posing constant risks. Waiting until the chaotic early epochs pass could be the ultimate survival strategy. By the time they wake, space will be quieter, safer, and infinitely more efficient, a paradise for minds built to think forever. So when we gaze at the silent stars, we might not be seeing absence. We could be looking at a universe holding its breath, counting down to a future so distant, our entire civilization will be less than a footnote. And the most humbling thought, by the time the estivators awaken, the stars they see won't be the ones we know. They'll be the cold, dark embers of a universe nearing its end, where the real work of existence is only just beginning. They could be watching us right now, not from distant stars, but from moments in time we haven't reached yet. The concept of time-traveling observers turns the Fermi Paradox into a temporal riddle. What if advanced civilizations don't just traverse space, but manipulate time itself, studying us like historians peering through a one-way window into the past? Think of humanity's own timeline as a book. We're somewhere in the middle chapters, flipping pages forward, while future civilizations might have the ability to revisit any passage at will. To them, Earth in the 21st century could be a museum exhibit, a pivotal era they're careful not to disturb. The prime directive from Star Trek takes on new meaning, not just avoiding interference with alien cultures, but preserving the integrity of causality itself. A single misplaced artifact or whispered message could ripple through history, altering timelines in ways even they can't predict. There's a haunting precedent in physics, the concept of closed time-like curves, solutions to Einstein's equations that theoretically allow for time loops. While we've never observed such phenomena, a civilization mastering quantum gravity or exotic matter might treat time as a navigable dimension. Imagine researchers from the year 50,000 observing ancient Rome or the Cretaceous period, not with telescopes, but by literally positioning themselves in those eras, cloaked by technology that renders them undetectable. Our skies might be full of temporal tourists, their presence hidden by advanced camouflage or simply by existing fractions of a second out of phase with our perception. But why wouldn't they reveal themselves? The answer might lie in the grandfather paradox. If future beings altered our timeline even accidentally, they could unravel the very conditions that led to their existence. A single interaction, no matter how minor, might create branching realities where their future never happens. The safest strategy: silent observation. No contact, no artifacts, no detectable footprints. To us, their absence would feel like cosmic silence, when in reality, we're surrounded by spectators frozen in a self-imposed quarantine of non-interference. There's another layer. What if these time travelers aren't human at all, but our own distant descendants? A post-human civilization might revisit pivotal moments in their evolutionary history, studying their origins with the same reverence we reserve for archaeological digs. The thought is equal parts awe-inspiring and unsettling, like realizing your childhood home was full of hidden cameras all along. The universe's silence wouldn't be emptiness, but a carefully maintained buffer between epochs. Every star, every planet, every moment in history could be under observation by civilizations who have mastered time but refuse to break its rules, and the most spine-chilling possibility: if they're here watching, they're doing so because they know something we don't about how our story ends, or worse, how it must end to ensure theirs begins. What if the aliens we've been searching for aren't out there in the stars but all around us, hidden in the very code of reality? Simulation theory offers one of the most provocative answers to the Fermi Paradox. The eerie silence of the cosmos isn't a mystery to solve, but a feature of the program. Our universe might not be the vast, physical expanse we perceive. It could be an unfathomably advanced simulation, created by beings so far beyond our comprehension, they're indistinguishable from gods. Think of it like this: when you play an open-world video game, the entire map isn't rendered at once. Distant mountains are low-resolution textures until you get closer, saving processing power. Now imagine our universe operates on the same principle. The empty cosmos we observe, just background assets simplified to conserve resources. Those twinkling stars aren't abandoned, they're placeholders, never meant to be inhabited, because the simulation's creators have no need to fill every pixel with life. Earth could be the main character's playground, while the rest exists as set dressing, a backdrop to make the simulation feel vast and authentic. This idea gains traction when you consider our own technological trajectory. Humanity has gone from punch cards to photorealistic virtual worlds in under a century. Given another 1,000 years or 1,000,000, our descendants might create simulations so detailed the inhabitants would never suspect they weren't real. Now reverse the perspective. What if we're already inside someone else's creation, built for purposes we can't fathom? The simulation's architects wouldn't need to populate other planets with life, because we're not the audience, we're the experiment. There's a chilling elegance to this version of the paradox. The absence of alien contact wouldn't be strange, it would be expected. Why would a simulation include other civilizations unless specifically required? Every unexplained cosmic phenomenon, dark matter, quantum indeterminacy, even the unsettling fine-tuning of physical constants, could be glitches in the code or intentional limits placed on the simulation's resolution. Our frustration at the universe's silence mirrors a video game character's confusion when they hit the edge of the map and find only empty skybox. But here's the twist that bends reality. The beings running our simulation might not even be aliens as we imagine them. They could be post-biological entities, their consciousness merged with the simulation's architecture, existing outside time and space as we know it. To them, our entire history from the Big Bang to this very moment might be a brief subroutine in a larger process, as insignificant as a single frame in a trillion-year calculation. The Fermi Paradox dissolves because there's no paradox at all, just layers of reality we're not programmed to see, and the most unnerving thought: if we're in a simulation, then every time we search the cosmos for signs of life, we're not exploring an actual universe. We're probing the boundaries of our cage, running up against the limits of someone else's design. The silence isn't a failure to find others. It's the sound of the simulation humming along exactly as intended, with Earth as the only exhibit in an otherwise empty gallery. What if the universe's silence isn't an accident but a deliberate strategy, a cosmic game of hide and seek where the winners are the ones who never get found? This is solution 24 to the Fermi Paradox. Advanced civilizations might be energy conscious to the extreme, minimizing their footprints not out of scarcity but out of caution. Imagine a predator-rich jungle where the smartest creatures don't roar or leave tracks, they become shadows, vanishing into the background. On a galactic scale, that could mean avoiding megastructures, radio broadcasts, or any other telltale signs that scream, "We're here." Consider the concept of Dyson swarms, vast arrays of energy-collecting satellites encircling stars to harness their full power. While we often imagine these as glittering, obvious constructs, a truly advanced civilization might engineer them to be stealthy. Instead of radiating excess heat into space, they could channel every joule into computation or storage, leaving no thermal signature. Their solar panels might be pitch black, absorbing every photon without reflection, their orbits designed to mimic natural debris. From a distance, their star would appear slightly dimmer, perhaps, but in a universe where stars naturally fluctuate, who'd notice? This isn't just paranoia, it's survival logic. Human history is littered with tragedies where more visible societies were exploited or destroyed by those with greater power. The same could hold true across galaxies. A civilization that broadcasts its location might attract not allies, but berserkers, whether alien empires or self-replicating killbots left over from ancient wars. The only safe move: stay dark, communicate through tightly focused neutrino beams or quantum-entangled particles that leave no trace. Build your cities inside hollowed-out asteroids, your ships camouflaged as comets. Let the universe think you're just another patch of empty space. There's a poetic irony here. We scour the cosmos for technosignatures, radio waves, laser pulses, megastructures, assuming intelligence announces itself. But the most advanced civilizations might follow the opposite rule: intelligence hides. Their greatest achievement could be making their presence indistinguishable from nature's randomness. The stars we study, the exoplanets we catalogue, they might already be occupied, their inhabitants deliberately engineered to be invisible to our crude detectors. And the most unsettling thought of all: if this strategy is universal, then the cosmos might be teeming with life, all playing the same silent game. Every civilization, independently realizing the danger of exposure, fading into the cosmic background like fireflies blinking out one by one. The universe isn't empty, it's a darkened theater where every player has learned the same lesson. To survive, you stay quiet, you stay small, and above all, you never turn on the lights. What if the universe isn't just indifferent to our existence, but empty by design? The solipsistic hypothesis takes the Fermi paradox to its most isolating extreme: the possibility that humanity is utterly alone. Not because others are hiding, transcending, or extinct, but because we're the only spark of intelligence the cosmos has ever produced. No ancient empires, no alien civilizations, not even microbial life beyond Earth. Just us floating on a pale blue dot in an unimaginable void. This idea cuts against everything we've been taught about probability. With trillions of galaxies, each with billions of stars and planets, how could life not emerge elsewhere? And yet, consider the sheer improbability of our own existence. Earth's history is a chain of cosmic accidents. A moon-forming collision, a stabilizing magnetic field, 1,000 extinction events narrowly survived. If even one of those variables had shifted, no oxygen, no dinosaurs, no mammals, we wouldn't be here to ponder the silence. The universe isn't obligated to fill itself with life just because space is abundant. There's a haunting symmetry to this idea. For centuries, humanity believed Earth was the center of creation. Science humbled us, revealing we orbit an average star in an unremarkable galaxy. But what if, in another twist, we are special after all, not in location but in essence? The cosmos may be a vast machine for generating a single conscious observer, us. Every supernova, every quasar, every spinning galaxy exists not to host others, but to set the stage for our brief, flickering moment of awareness. Some physicists argue that life's emergence requires such precise fine-tuning of physical constants that Earth might be a one in a googolplex anomaly. Imagine rolling a die with 1 trillion sides and landing on the same number 100 times in a row. That's the kind of luck we might be looking at. Even if the universe is infinite, infinities don't guarantee repetition. There could be endless stretches of sterile space between islands of life so distant they might as well not exist. The psychological weight of this hypothesis is crushing. If true, it means every war, every love story, every whispered dream is contained within a bubble of solitude no signal will ever breach. The stars we admire are forever out of reach, not because we can't cross the distance, but because there's nothing, and no one waiting on the other side. The night sky isn't a backdrop for alien civilizations, it's a mirror reflecting back our own isolation. Yet there's an unexpected liberation in this loneliness. If we're the universe's only voice, then every act of creation, every scientific discovery, every burst of art becomes a sacred act of cosmic significance. We're not just inhabitants of the universe, we're its storytellers, its archivists, its only chance to know itself. The silence isn't a failure to connect. It's an invitation to fill the void with meaning, one fragile human moment at a time. What if the great cosmic explorers we imagine, the starfaring civilizations building Dyson spheres and colonizing galaxies, never existed at all? Not because they couldn't, but because they simply didn't want to. This is the quiet revolution of Solution 26, the idea that advanced alien societies might have transcended scarcity so completely they lost all interest in expansion. Imagine a civilization that's not just technologically superior, but philosophically unrecognizable to us, one where every material need is met, every curiosity satisfied, and the very concept of more has vanished. Think about humanity's own obsession with growth. Our history is a treadmill of conquest and consumption, new lands, new resources, new horizons. But that drive is rooted in something primal, the fear of not having enough. Now picture a society that cracked the code of abundance millions of years ago. With nanotechnology disassembling asteroids atom by atom, fusion reactors delivering limitless energy, and AI managing perfect resource distribution, why would they need to conquer the stars? Their version of progress might look less like outward expansion and more like inward refinement, centuries spent perfecting art forms we can't comprehend, or meditating on questions we haven't even thought to ask. There's precedent for this even in human history. Take the Indus Valley civilization, which thrived for nearly 2,000 years without evidence of war or grand monuments to conquest. Or Japan's Edo period, where 2 centuries of isolation led to flourishing arts and philosophy. Now scale that up to a galactic level. A post-scarcity civilization might view interstellar travel the way we view climbing Everest, possible, but pointless unless you're seeking a specific kind of suffering. Their utopia could be so fulfilling, the mere idea of leaving it seems absurd. Why brave the void when your world is a paradise of endless discovery? But here's the twist. Post-scarcity doesn't just eliminate the need for expansion. It might erase the desire for contact too. If a civilization has AI companions tailored to their every thought, virtual realms more vibrant than reality, and no unmet needs, what would they gain from talking to us? We might be like ants trying to strike up a conversation with a philosopher lost in sublime thought. Even if they noticed our signals, responding could feel as irrelevant as stopping a symphony to answer a wrong number phone call. The frightening beauty of this idea: the universe might be crowded with utopias, each one a shimmering, self-contained jewel, utterly disinterested in the world beyond their atmosphere. The Fermi Paradox wouldn't be about absence or failure. It would be the sound of 1,000 perfect societies, all whispering the same silent truth: we have everything we'll ever need. Gamma-ray bursts are the universe's silent assassins, cosmic sniper shots capable of sterilizing entire galaxies in the blink of an eye. Imagine a single beam of energy, packing more power than a star will emit in its entire lifetime, focused into a jet narrower than a pencil's width. If one of these beams were to sweep through a solar system, it wouldn't just kill life, it would erase the very possibility of life for millions of years. The atmosphere would boil away, oceans vaporize, and the surface of any planet in its path would be scoured down to bare rock. This is the heart of the cosmic catastrophe theory, that the universe isn't just indifferent to life, it's actively hostile. Consider the evidence. Earth itself has narrowly escaped annihilation multiple times. In 2008, astronomers observed a gamma-ray burst so powerful that, had it occurred within 10,000 light-years of us, it would have triggered a mass extinction. The burst originated in a galaxy billions of light-years away, meaning it actually happened billions of years ago. We just dodged the bullet by being in the wrong place at the right time. And gamma-ray bursts aren't the only threat. Supernova, hypernova, even rogue black holes could scour entire regions of space clean with terrifying regularity. The universe might not be a graveyard of civilizations. It could be a firing range where life keeps emerging only to be wiped out before it ever gets the chance to shout into the void. The math here is chilling. Gamma-ray bursts are estimated to occur once per galaxy every few million years. That might sound rare, but remember, the Milky Way is 13 billion years old. That's enough time for thousands of these events, each one potentially resetting the clock on intelligent life. A civilization might rise, develop radio technology, even begin space exploration, only to be vaporized mid-stride, leaving no trace behind. The universe wouldn't just be silent, it would be a symphony of false starts, with every melody cut off before the first note is fully played. But there's an even darker layer. Some of these catastrophes might be inevitable. Take solar flares. Our own sun is capable of eruptions that could fry Earth's electronics, sending us back to the pre-industrial age. Now imagine a superflare from a young, unstable star or a nearby magnetous burst of radiation. These events don't just kill civilizations, they erase the conditions that allowed them to exist in the first place. A planet hit by a gamma-ray burst might lose its atmosphere entirely, becoming a barren rock for billions of years. The Fermi Paradox wouldn't be a question of where everyone is, it would be a tally of how many times the universe has pressed the reset button. The unsettling truth: we might not be alone. We might just be the current survivors in an endless cycle of cosmic genocide, standing on the bones of civilizations that never got the chance to leave their mark. And one day, unless we get very lucky or very smart, our turn might come. The universe doesn't just kill, it kills without warning, without remorse, and without a single witness left to tell the tale. Beneath the frozen deserts of Mars, under the acidic clouds of Venus, deep in the oceans of distant moons, what if the universe's most common life forms aren't looking up at the stars but down into the dark? The underground hypothesis offers a radical twist on the Fermi Paradox. Intelligent life might be everywhere, just not where we're searching. Imagine civilizations evolving in labyrinthine cave networks around hydrothermal vents or in vast subsurface aquifers environments so isolated they'll never dream of spaceflight, let alone achieve it. Take Europa again, not its icy surface but the global ocean beneath. A species evolving there would face a ceiling literally made of rock-hard ice miles thick. Even if they developed intelligence, their entire world, you would be shaped by perpetual darkness and crushing pressure. Concepts like sky or stars might be mathematically theorized but never seen. Their technology would adapt to their environment, perhaps bioengineered organisms to illuminate tunnels or pressure-resistant structures grown from mineral deposits. Spacecraft, impossible. The energy required to melt through the ice shell alone would dwarf anything their ecosystem could provide. Earth itself hints at this possibility. The subsurface biosphere, a hidden world of microbes living kilometers below our feet, rivals the surface in mass. In gold mines and deep boreholes, scientists have found life thriving in cracks filled with ancient water, isolated for millions of years. Now imagine that on a planet where surface conditions are lethal, constant radiation, scorching heat, or toxic atmospheres. Life there wouldn't just prefer the underground, it might never discover the surface at all. The implications rewrite our assumptions about intelligence. We picture alien cities with towering spires, but they could be sprawling mycelial networks or crystalline cavern metropoles. Communication might happen through seismic vibrations or chemical trails, methods invisible to our radio telescopes. Even their history could be encoded in sedimentary layers or geothermal cycles rather than books or satellites. And here's the kicker, these civilizations could be far more common than surface dwellers like us. Underground environments are stable, shielded from asteroid impacts, solar flares, and climate shifts. A planet's crust might be the only place life can survive long enough to evolve complexity. The universe could be teeming with such societies, each forever contained by their own geology. The Fermi Paradox dissolves when you realize we've been searching for neighbors who built antennas, not those who perfected the art of whispering through stone. The cosmos isn't silent, we've just been listening for the wrong echoes in all the wrong places. What if the universe itself has built-in limits not just on speed, but on communication itself? The quantum communication barrier suggests that interstellar conversations might be fundamentally impossible, not because civilizations don't exist, but because the cosmos enforces a strict speed limit on information. Imagine two people stranded on opposite sides of a canyon, shouting into the wind. Even if they hear each other's echoes, the delay makes real-time conversation meaningless. Now scale that up to light years, where the delay isn't seconds, it's centuries. The problem isn't just distance, it's quantum mechanics. According to our current understanding, no information can travel faster than light. Quantum entanglement offers spooky connections between particles, but even that can't transmit meaningful data instantaneously. A civilization orbiting Proxima Centauri could entangle particles with us, but deciphering changes in those particles still requires conventional light-speed signals to compare results. The universe, it seems, is hardwired to prevent shortcuts. This isn't just theoretical. Human attempts at quantum communication, like China's Misha satellite, have achieved breakthroughs, but they still rely on classical channels to verify results. The dream of faster-than-light dialogue crashes against the unyielding wall of physics. For alien civilizations, this could mean that even with advanced technology, sending a message to another star system is like mailing a letter into a black hole. You'll never know if it was received, let alone understood. The implications are profound. A galaxy teeming with life might still be silent because every attempt at contact drowns in the noise of cosmic lag. Civilizations could be separated not just by space but by time, their messages arriving millennia too late, their senders long gone. The universe's great irony, it's vast enough to cradle countless minds but rigged to keep them eternally isolated. Perhaps this is why we hear nothing. Not because no one's speaking, but because the universe muffles every voice before it can ever be heard. We might not be latecomers to the cosmic stage, we could be the opening act. The universe is 13.8 billion years old, but that doesn't mean it's ready for life. Think of it like a simmering pot of ingredients. The first stars were pure hydrogen and helium, lacking the heavier elements necessary for planets or biology. It took billions of years of stellar explosions to forge carbon, oxygen, and iron in the hearts of dying stars, scattering them across galaxies like seeds. Earth formed relatively early in this process, just 4.5 billion years ago. What if we're not just lucky, but pioneers, the first species in our corner of the cosmos to wake up and stare at the stars with wonder? Consider the timeline. Complex life on Earth required more than just the right elements. It needed a stable, nurturing environment for billions of years. Early galaxies were violent places, riddled with radiation from quasars and collisions. Only in the last few billion years has the universe quieted enough for fragile DNA to survive uninterrupted. Even now, most stars in the Milky Way are cooler, longer-lived red dwarfs, some stable enough to host planets for trillions of years. Civilizations orbiting those stars might be dormant, their planets still baking in primordial soups, their evolutionary clocks ticking far slower than ours. We didn't emerge in a crowded universe, we might have arrived just as the doors opened. This perspective flips the Fermi Paradox from a puzzle to a privilege. The silence isn't a warning, it's an invitation. If we're among the first, then the cosmos lies before us like an untouched frontier. The galaxies aren't graveyards, they're blank pages waiting for our stories. Imagine future historians looking back at this era as the dawn of something monumental, the moment life first reached beyond its cradle and began the long, slow work of filling the universe with light. But there's a loneliness to this idea too. If we're early, then every unanswered signal, every empty exoplanet, is a reminder that we're dancing alone in a ballroom built for trillions. The stars we admire might flicker on for billions of years before another voice finally answers. Until then, every question we shout into the dark is also a promise, a declaration that someone was here first, that the universe was noticed, that it mattered. Whether this truth fills you with awe or melancholy, one thing is certain. If we're among the first, then the greatest adventures and the greatest responsibilities are still ahead. The cosmos didn't evolve us to hide in the shadows. It shaped us to reach, to explore, and perhaps one day to welcome the next ones who wake up beneath a foreign sky and whisper, "Are we alone?" Only then will they hear the echoes of our answer, carried across time itself, not anymore. From optimistic visions of cosmic civilizations waiting to awaken, to chilling scenarios where advanced societies hide in fear or silence, the Fermi Paradox offers more than 30 possible answers, each one a window into how we view our place in the universe. Some theories fill us with awe, like the idea that we're pioneers in a young cosmos destined to light the way for others. Others unsettle us with their implications, that intelligence might be fleeting or that the universe is a carefully curated prison. But perhaps the most profound lesson isn't about aliens at all. It's about us. Every solution to the paradox reflects a different facet of human nature. The dark forest hypothesis speaks to our fear of the unknown. The zoo hypothesis mirrors our ethical dilemmas, and the simulation theory questions the very fabric of our reality. Wrestling with these ideas forces us to confront our own fragility, curiosity, and ambition. Are we special or just lucky? Are we alone or surrounded by voices we can't yet hear? The silence of the cosmos isn't just a scientific puzzle, it's a mirror held up to humanity's hopes and anxieties. So what's your take? Do you find comfort in the rare Earth hypothesis, or does the great filter keep you up at night? Maybe you're convinced we're living in a simulation, or that advanced civilizations are hibernating until the universe cools. Drop your favorite theory in the comments. I'd love to hear which explanation resonates with you. And if you enjoyed this deep dive into the universe's biggest mystery, don't forget to subscribe. We've barely scratched the surface of space's enigmas, and there are plenty more cosmic puzzles to explore. Until then, keep looking up. The answers might be out there, or they might be closer than we think.